I'm going to introduce Pandas as basically an extension to NumPy, which is basically what the Pandas really is. Pandas is going to be the thing that you are going to use almost all the time, like every day as a data scientist. It is not the be-end-all tool, some phrase, something, the only tool you'll use, but it'll be a really important tool that you'll probably use almost every day. And then you'll always want to use Pandas. At least I always do. So Pandas from NumPy. So one thing to note, also know that Pandas has now officially reached 1.0. I don't know if you guys have seen this in the news, like tech news stuff. But Pandas is 1.0, I think as of last week, if I remember this right. It's official and stuff like that. So yay, it reached 1.0, which means absolutely nothing for computer stuff because who knows who's counting. Anyway, it's a typical tool for data scientists. It's basically something that you should feel very comfortable with. If you are doing a technical interview, you are going to be using Pandas most likely in that technical interview, whether that's live in front of someone else or doing a take-home assignments and stuff like this. I would probably say probably the three biggest tools that every data scientist should really understand how to do is using Pandas, using scikit-learn, and using SQL. We're talking about Pandas now. SQL will be next week, and scikit-learn will start touching about that, I think, into mod 2. And that's where I think if you know those basics, I think that would get you pretty far into an entry-level position for data science. Okay, so I won't go into full detail. Again, I swear Jake Vanderfoss is not like paying me or something, but I will push this forward. I guess I don't know how you'd pay me. I'm telling you to get it for free or whatever. But again, a great resource to do this. All right, so some quick objectives. We'll see, we got like about 12 minutes left of the day, so we'll see how we can get through. But main thing we're going to talk about is saying, hey, what is this Pandas? How are we using it? And I'm basically going to show you, hey, here's a series, here's a data frame. Don't worry what that is right now, but it's going to be related to NumPy. And then saying, okay, we're going to try to do some data manipulation with it, as well as accessing data in Pandas. Okay, and this will lead us into really well into section 5, where section 5 is about using that information to actually do like cleaning and finding missing values and doing some exploration. And don't worry if we're not going to get through it today because we'll see it again for sure. All right, so we're going to import NumPy because we just love NumPy, and then Pandas. Also know that you can also use emojis in Python code. Probably don't do that though, just because, I mean, I guess you could, like, but don't do this professionally. But like you can import Pandas as like, oh no, you can't do it. I thought you could. You can generally use emojis for your variables, but it's completely legit, but don't do that. Anyway, so we're going to import Pandas as PD. That's usually the typical way we import. And we're going to talk about series and data frames. So when look at, like, you don't have to look at me, but like, I want you to hear me. What I'm saying is that when I say a data frame, I want you to instantly think spreadsheet. Like that is what a data frame is. When I say data frame, just like you're like spreadsheet, I know exactly what that is. Everyone knows what a spreadsheet is, right? Thank goodness. All right, if you guys know what a spreadsheet is, like, all right, like we're gonna have to go back. But yeah, so think of a spreadsheet as a data frame, and that's really what's going on here. A series is really just like a column in the spreadsheet, right? Or a column technically can be a row. And so what we talk about as a data frame and series, those are really the parts of Pandas of like how we're gonna store data and organize data. A series is basically just a one-dimensional array, basically just a string, I don't want to say string, a list of numbers, whether that's the column or a row. Usually we'll talk about it as a column, but it can't be a row. A data frame is just basically a two-dimensional array. So like a spreadsheet where we have basically a bunch of columns. Okay, makes sense? I know that was super complicated, but like, yeah, good, awesome. All right, so some quick examples. All right, so I'm using Pandas, pd.series. I'm creating a series, just like we did like NumPy np.array. Hey, it's kind of similar, you can see that. And what's kind of cool is that with NumPy, if I did this, and I'm going to kind of ruin my code here for a second, but if I do a NumPy array, you can see here, hey, you got an array, right? And we have the list of numbers. So a series, what it does is something very similar, but it'll actually have some extra information. And so you'll see here, hey, there's 0, 0.2, 0.4, 0.6, 0.8, 1.0. You'll also notice this D type float. I'll give you a secret. NumPy actually keeps this information there. It just doesn't like to show it to you unless you need it. But series will actually show you every single time what this type is. So in a series, just like a NumPy array, every element in there has to be the same type, okay? So if I put, for example, you can put strings. If I put a string on this from this guy, has anyone got a guess what this D type will be? Take your best guess.
Object, a category.
Object, yes, cool. It's actually wrong now with 1.0. 1.0 actually uses string, but at least for the NumPy we're using, you'll see object and stuff like that. But yes, it basically converts all of these numbers into string or objects and stuff like this. So note that that is a difference with a list versus like, a series, but series is just like a NumPy array. Okay, so cool, we got a series. Okay, we can also do, you can notice there's like 0, 1, 2, 3, 4. This is what we call their index. Basically, series also keeps kind of like, it's kind of like a list where we have like the numbers, but it's almost like an advanced dictionary. Like you can think of it like the first key is the 0, the second key is the 1. We can also have like an index. We can actually define our index. For example, I have a list of A, B, C, D, E. You can see here, that's how we identify each element in there, saying, oh, it's the 8th or A, I don't know how to say this, but like the row that is represented with A. Okay, you can see here I do something similar with a different set of numbers. So you can see here A, B, C, D through E, and then I can actually combine this together. So I can actually create a data frame now from this data column. So it'll take this data column and it'll create a data frame. And what's really cool is that, remember this is calling display data frame. If I print this out, it has this nice, very pretty structure. You can see here, here's our index, and you say, oh, look at that highlight right there, 0.2, 0.4, 0.6. And you can see here, it automatically names the column. It's like, hey, you didn't give me a name for the column. I'm just gonna call it column 0, okay? So Pandas kind of works a little bit in the same way as me. So I'm not super creative. Pandas not very creative until you tell it to be. All right, you can also do multiple series. So you can actually say, okay, we have data column, which is this guy, data call other, which is gonna be my other column. You can see I'm not super creative. And then the column name is first column, second column. So if I do this now, it will actually create 2 columns. And you can see here, hey, look at that. It even organizes it by the index. You can see A, B, C, D, E. Okay, note that if I didn't have the index in here, so just kind of quickly show you guys what this looks like. Get rid of these comments. So you see the index like this. If I run this guy, you can see the index right here is copied over. Okay, cool. So let's see here. I'm going to put this back because I might actually need these indexes in there. There we go. Okay, so one thing you can see, okay, we got our little index in here. What if instead I take this column, so I have 2 different columns here, or sorry, 2 different series, and you can see I use different indexes. So you can see this is A, B, C, Z, Y, right? So you can imagine this is going to be like A, B, C, Z, Y, and this one has A, B, C, D, E. If I combine these together, what do you think is going to happen? Will it look like this? Or not look like this? Hold on your horses, we'll find out. So you can see here is that it actually almost works that way, A, B, C, D, E. And then you can see on the second column, because there was no DE here, it actually has NaN value, it means missing. It doesn't know what this value is supposed to be. So you can see here is basically, we call these like missing values. And you can see on the opposite side, because Z and Y were here, right, Z and Y, it actually doesn't know what the first column is because it never had a ZY here. So this is kind of a show a little bit like how you can combine data. So for example, if I did now have, let's say I say, oh, the Z element should be 1.2, you'll now see is that it'll fill up right here. Okay. So this is kind of how these data frames kind of are created from these lists, a bunch of series. Okay, make sense? Sound good? Any questions? Cool. All right. So kind of quick thing. This is usually I say like, why would you use a data series? Why would you use a series versus a data frame? Or like, not versus a data frame, but why do we use these instead of like lists and dictionaries and stuff like this? Short answer basically is that we use them because they're better than dictionaries. They're basically advanced dictionaries. They're a great way for us to hold onto our data and organize our data and be able to use some extra functions that are going to be built into Pandas that we can basically operate in. And also, because it's using NumPy underneath, it actually makes it much faster than if we were typically trying to make like a list of lists. So that's why Pandas is so useful. Okay.